Integral of square root of x divided by a cube minus x cube dx. We have to calculate this integral. Now we look at the denominator part. It is like 1 by square root of a square minus x square. Can we get into that format? Then I know that the integral for that will be sine inverse of x by a. So let's go ahead and see how we can do that. For that we'll say integral of numerator square root of x, we'll write it as x power 1 by 2 divided by square root of a cube. We have to write it as a perfect square. So we will say a power 3 by 2 whole square minus x cube. Again we have to make it as a square. So we will say x power 3 by 2 whole square, and we have dx. Now you can also see that if I take x power 3 by 2 as a particular variable t, then the numerator x power 1 by 2 is a part of that. Let us see. So we'll say for that x power 3 by 2, let x power 3 by 2 equals to t. Now differentiating, we will have 3 by 2 into x power 1 by 2 dx is equals to dt. 3 by 2 into x power 1 by 2 dx equals to dt. That means x power 1 by 2 dx, what we have there is nothing but equals to 2 by 3 dt. So we can come back to our problem and we say that this is nothing but 2 by 3, and x power 1 by 2 dx will vanish and I will get dt here, and this will come into standard integral form of a power a square minus x square. I have a power 3 by 2 whole square minus t square. And for that we know the answer will be 2 by 3 into sine inverse of x by a. Here our x is t and a is a power 3 by 2. Now since we have been given the problem in terms of x and we have taken variable t for our convenience, so we have to go back to our where we started, that is in terms of x. So it will become 2 by 3 sine inverse of t is x power 3 by 2. So the power is common, so we can write down x by a whole to the power of 3 by 2 plus c. So the integral of square root of x divided by a cube minus x cube dx is equals to 2 by 3 sine inverse x by a whole to the power of 3 by 2 plus c.